Hello, everyone. My name is Keegan Harris, and I'm a PhD student at Carnegie Mellon University. Today, I'll be talking about stateful strategic regression. This is joint work with my advisors, Hoda Heidari and Stephen Wu. Machine learning models and algorithms in general are increasingly used to assess individuals' qualifications for high-stakes opportunities. Some example domains in which ML models are used to make decisions about people include lending, education, and employment. When strategic agents are evaluated by algorithmic assessment tools in high stakes situations, they will modify their features in order to achieve a more favorable outcome. With this in mind, the goal of decision makers in the strategic regression setting is to design decision making tools that are robust to strategic learners. This robustness can come in the form of several different objectives for decision makers, including predictive risk minimization, agent outcome maximization, and causal parameter recovery. However, our focus is on designing assessment rules in order to incentivize the agent to spend effort in certain desirable directions. For example, consider the setting in which a teacher gives a student an assessment. The goal of the teacher is to get the student to learn the material, while the goal of the student is to get a good grade on the assessment. If the teacher only gives the student one assessment, it may be easier for the student to cheat in order to get a good grade instead of study. However, if the teacher gives the student multiple assessments that each build off of one another, then the student may be forced to study in order to do well on all three. We aim to capture this intuition in our stateful strategic regression setting. While previous work considers one-shot interactions between a decision maker and decision subject, many real-world settings are not captured well by this interaction model. For example, students taking a class are usually evaluated several times by their teacher throughout the semester, instead of just once. Our goal is to leverage these multiple interactions in order to give the principal additional latitude towards accomplishing their goals. Like previous work, we model the interaction between principal and agent as a stackable game. However, in our setting, the principal announces a sequence of assessment rules with the goal of maximizing the cumulative effort the agent expends in certain desirable directions. The agent then best responds to the entire sequence of assessment rules by spending effort at every time step in order to maximize their cumulative effort across all rounds. Under this formalization, we are able to characterize the game's Stackelberg equilibrium. By modeling the interaction over multiple time steps, the principal is more effective at incentivizing agents to invest effort in desirable characteristics, such as studying instead of cheating in the classroom setting. Next, we show that for every optimal assessment policy, there exists an optimal linear assessment policy, which can incentivize the same set of efforts. We do this by characterizing the notion of a dominated effort policy, basically an effort policy which no rational agent would ever play using a linear program. And we show that if an effort policy is not dominated, a subset of the dual variables correspond to a linear assessment policy which can incentivize an agent to play it. This is important because it means that the principal does not have to sacrifice optimality for the sake of model interpretability. While the space of optimal principal and agent policies is non-convex in general, we provide polynomial time algorithms to recover the optimal principal and agent policies in settings where the dynamics of the system can reasonably be thought of as linear. We recover the agent's optimal effort policy by solving a sequence of linear programs and use a membership oracle-based convex optimization procedure to recover the principal's optimal policy. In conclusion, we formalize the interaction between a principal and agent in the strategic regression setting, which plays out over multiple time steps. By considering multiple rounds of interaction, desirable effort profiles can be incentivized under a wider range of settings compared to models which only model strategic interactions in a one-shot manner. Under this setting, we characterize the game's Stackelberg equilibrium and provide tractable algorithms for computing both the principal and agent's optimal policies when the dynamics of the model are linear. We also show that linear assessment policies are optimal for incentivizing the agent to expend effort in certain desirable directions. Thank you.